name is Ms.K.Nithyakalyani. I am going to teach you about the nomenclature of the polyfunctional compounds. So, what do you mean by the nomenclature of polycyclic hydrocarbons? In addition to such a monocyclic compounds, a larger number of the polycyclic compounds are also known. They contain two or more rings having two or more carbon atoms in common. So, in addition to such a monocyclic compounds, a larger number of the polycyclic compounds are also known. They contain two or more rings having two or more carbon atoms in common. Systematic naming of a compounds having more than one ring is done by putting the prefixes bicyclo, tricyclo, etc. before the name of the alkane, denoting the total number of the carbon atoms in the ring. In addition to such a monocyclic compounds, a larger number of the polycyclic compounds are also known. Mono means single, poly means many. They contain two or more rings having two or more carbon atoms in common. Systematic naming of compounds having more than one ring is done by putting a prefixes bicyclo, tricyclo, etc. before the name of the alkane, denoting the total number of the carbon atoms in the ring. The ring carbon atoms are now numbered commencing with any one of the carbon atoms at the junction. So the ring of the carbon atoms are now numbered commencing with any one of the carbon atoms at the junction, and it is continued to the next junction at the longest path. Maximum number of the carbon atoms and then a shortest path, successfully finally the shortest path. The number of carbon atoms involved in each of these paths is written in a square bracket in descending order, which is inserted in between the word bicyclo and alkane. The following example will explain these rules. The ring carbon atoms are now numbered commencing with any one of the carbon atoms at the junction. This continue to the next junction, first along the longest path, maximum number of the carbon atoms, then the shortest path, successfully finally along with the shortest path. The number of the carbon atoms involved in each of these paths is written in a square bracket in descending order, which is inserted in between words bicyclo and alkane. That is, the carbon atoms are now numbered commencing with any one of the carbon atoms at the junction, and it is continued to the next junction for the first along with the longest path. Maximum number of the carbon atom, then a shortest path, successfully finally the shortest path. The number of carbon atoms involved in each of these paths is written in a square bracket in the descending order, which is inserted in between words bicyclo, alkane. The following example will explain these rules. Here is the example for bicyclo: 2,2,1 heptane, nor borane, and then 2-ethyl, 3-methyl bicyclo, 2,2,2 octane. So IUPAC name for the compounds containing one functional group, multiple bonds, and substituent. So general IUPAC nomenclature of the compounds containing some functional groups, substituent groups, one functional groups, and then multiple bonds. Multiple means many of double and triple bonds included. The basic rules for the IUPAC system, illustrated with the help of the suitable examples, are discussed below. The longest possible continuous chain of the carbon atoms containing the functional group and the maximum number of the double and triple bond, if any, are identified as the word root corresponding to it is noted. So first rule is the longest possible continuous chain of the carbon atoms containing the functional group and the maximum number of the double or triple bonds, if any, are identified and word root corresponding to it is noted. Carbon atom containing a functional group and the maximum number of the double and triple bonds, if any, are identified. First, they are identified and the word root corresponding to it is noted. So, one longest possible carbon atom, one principal chain, multiple double and triple bonds are also identified, and the functional group is also identified. And these are after the identification, the word root corresponding to that system is often noted. All the atoms and the groups or side chains present are regarded as the substituents. So, all the atoms and groups are the side chains are noted as a substituents. While deciding the principal chain, the functional group should always be included, irrespective of whether the principal chain also denotes the longest chain or not. The following example will make this point clearer. So IUPAC nomenclature of the compounds containing one functional group, multiple bonds, and substituent. The basic rules of a IUPAC system, illustrated with the help of suitable examples, are discussed below. The longest possible continuous chain of the carbon atom containing functional group and the maximum number of a double or triple bond, if any, are identified, and the word root corresponding to it is noted. All the atoms and the groups of the chains are present on it and regarded as a substituents. While deciding the principal chain, the functional group should always include it, irrespective of whether the principal chain also denotes the longest chain or not. The following example will make this point clear. So, this is nothing but all the atoms or groups or side chains present on it or regarded as the substituents. While deciding the principal chain, the functional group should always be included irrespective of whether the principal chain also denotes the longest chain or not. The following example, that is here, functional group is there. So 1, 2, 3, 4, 5, here 2, 1. So this is in the alphabetical order. We are naming it. So 2-ethyl is 2-ethyl butane 1-all. First question, all alcohol. So in this alcohol, the longest carbon chain containing 5 carbon atoms, but does not include the functional group OH. However, if the functional group is to be included, the longest possible carbon chain containing only 4 carbon atoms. So in this alcohol, the longest carbon chain containing 5 carbon atoms, it does not include the functional group OH. However, the functional group is to be included. In alcohol, the longest carbon chain containing 5 carbon atoms does not include the functional group alcohol. However, the functional group is to be included in the longest possible carbon chain containing only 4 carbon atoms. Hence, in accordance with the above rule, shorter carbon chain containing the functional group is selected as the principal chain. So, this is selected as the principal chain. So, yes, this is selected as a principal chain. Okay. In this alcohol, so the longest carbon chain containing 5 carbon atoms, but does not include the functional group. So functional group is to be included in the longest possible carbon chains containing the 4 carbon atoms. So here, this functional group should be included. So it is considered as the main chain, principal chain. Numbering the principal chain. Principal chain in a compound must be numbered in such a way that the functional group gets the lowest possible number, followed by the double and triple bond and the substituents. A functional group, double and triple bond, substituent. That is functional group, order-wise, priority-wise, functional group. Order-wise, priority-wise, functional group, double bond, triple bond, as well as substituents. So, numbering the principal chain. Principal chain is a compound in which numbered in such a way that the functional group gets the lowest possible number, followed by the double bond, followed by the triple bond, and then substituents. So, for example, where is the functional group? So, here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 here. Second position is a alcohol is there. So 3, 4, trimethyl, methyl. So trimethyl pentane 2-all. Second position alcohol is there. So 3, 4, 4. That is trimethyl, 3-methyl group, pentane 2-all, 5 carbon atoms so far. Pentane 2-all. Naming the principal chain, selecting the appropriate word root denoting the total number of the carbon atoms in the principal chain. Selecting the appropriate word root denoting the total number of the carbon atoms in the principal chain. So first rule is selecting the appropriate word root denoting the total number of the carbon atoms in the principal chain. Attach the primary suffix ane, ene, yne after the word root depending upon the principal chain is alkane, alkene or alkyne respectively. Positional number of the locants, that is the primary suffix, is indicated before the primary suffix. That is secondary suffix is indicated before the primary suffix. Here they have given mistaken. So naming the principal chain is nothing but three that is a rule. Rule one is selecting the appropriate word root denoting the total number of the carbon atoms in the principal chain. Attach the primary suffix ane, ene, yne after the word root depending upon whether the principal chain is alkane, alkene or alkyne respectively. Positional number of the primary suffix is indicated before secondary suffix is indicated before the primary suffix. Attach the secondary suffix for the functional group after the primary suffix. That is, we have to attach the secondary suffix of the functional group after the primary suffix. Positional number of the secondary suffix is indicated before the secondary suffix. So that is locants. That is the locant. So once again, I will repeat. IUPAC nomenclature of the compounds containing one functional group, multiple bond and one substituent. So the substituent, the basic rules of the IUPAC system illustrated with the help of suitable examples or discussed below. So the longest possible continuous chain of the carbon atoms containing the functional group and the maximum number of double as well as a triple bond are identified and the word root corresponding to it is noted. All the atoms or the groups or side chains present on it is regarded as the substituents. While deciding the principal chain, the functional group should always be included irrespective of whether the principal chain also denotes the longest chain or not. The following example will make this point clear. So the basic rules for the IUPAC system is the first rule is the longest possible continuous chain of the carbon atoms containing the functional group and maximum number of the double and triple bond are identified and the word root corresponding to it is noted. Second point, all the atoms and the groups and side chains are recorded as the substituents. While deciding the principal chain, the functional group should always include it irrespective of whether the principal chain also denotes the longest chain or not. The following example makes this clear. So here the functional group, so this is considered as the principal chain. In this alcohol, the longest carbon chain, 5 carbon atoms, but does not include the functional group alcohol. However, the substituent only including the functional group, so that is named as a principal chain. Hence, in accordance with the above rule, the shorter carbon chain containing the functional group, it is selected as the principal chain while giving it an IUPAC name. So in this alcohol, the longest carbon chain containing 5 carbon atoms but does not include the functional group OH. However, the functional group is to be included. The longest possible carbon chain contains 4 carbon atoms. Hence, in accordance with the above rule, the shorter carbon chain containing the functional group is selected as the principal chain while giving it an IUPAC name. Numbering the principal chain. Principal chain in a compound must be numbered in such a way that the functional group is the lowest possible number, that is followed by the double and double bond, followed by triple bond, and then substituents. So naming the principal chain, select the appropriate word root. First point. Second point is nothing but attach the primary suffix ane, ene, yne after the root word depending upon the principal chain is alkane, alkene or alkyne that we have understood. Attach the secondary suffix of the functional group after the primary suffix. Positional number of the secondary suffix is indicated before the secondary suffix. So numbering the chain terminating the functional group. When a chain terminating the functional group such as aldehyde, cyano, ester, carboxyamido, carboxychloride, which is present in always given position number 1. The number 1 is usually omitted from the final name of the compound. That is, when a chain terminating the functional group such as aldehyde, cyano, cyanonitrile, ester, as well as carboxyamido, carboxychloride, etc., it is present in, it is always given positional number 1, and the number 1 is usually omitted from the final name of the compound. Alphabetical order of the prefixes. The prefixes and the other substituents should be placed in an alphabetical order before the word root. For example, so this is the example. So number 1, 2, 3, 4, 5. So this is considered as a parent chain. So 2-ethyl, yes. So 2-ethyl. Second question, 2-ethyl pent. Okay, pent. One all. First position all. Okay. So next is a we are giving numbering to functional group followed by the double bond, followed by the triple bond, followed by the substituent. So 1, 2, 3, 4, 5, 6. Okay, hexa. Okay, hexa. So fourth position, yes, pro P, 3 carbon atoms, pro P, hex. Fifth position, E and E. Second position, 1 ketone. So 2, 1. Here 3 chloro, 2 methyl butanitrile. 3 chloro, okay. Here only we are giving number 1, 1, 2, 3, 4, hepta. So, sorry, buta. Four partner is buta. First position nitrile, okay. Third position chloro, okay. Second position methyl here. Next 3 phenyl pro 2 enoic acid. So why we are in? So this was E, this was oic acid. That is carboxylic acid. So enoic acid. So for second position only enoic acid. So 3 phenyl, yes, phenyl. 3 carbon atoms. So probe 2 enoic acid. So here pent 3 in 1 all. So here 5 carbon atoms. So 1, 2, 3, 4, 5. 5 carbon atoms. So pent. So third position E, in. So 1 all. 1 all. Okay, OH. So 1 all. So here butonate, O8. So ethyl, yes, ethyl. 2 methyl buta O8. That is here keto group. So O8. Nomenclature of the polyfunctional compounds, organic compounds, which contain 2 or more functional groups are called as a polyfunctional compounds. Their systematic names are obtained as follows. So nomenclature of the polyfunctional compounds, that is organic compounds which contain 2 or more functional groups are called as a polyfunctional compounds. Their systematic names are obtained as follows. Principal functional group and the secondary suffix. When an organic compound containing 2 or more different functional groups, the highest priority group, the priority order is given below, is selected as a characteristic group or the principal functional group or main functional group, while all the remaining groups are called as a secondary functional groups, treated as a substituents. So nomenclature of the polyfunctional. Many functional group is attached to one of the organic compound. Organic compound containing 2 or more functional groups called as a polyfunctional group. Its systematic name or applied as follows: principal functional group and the secondary suffix. When an organic compound containing 2 or more different functional groups, the highest priority group, the priority order given below, it is selected as the characteristic group or principal functional group or main functional group, while all the remaining groups are called as a secondary functional groups and are often treated as a substituents. So main functional group and the secondary suffix, an organic compound containing 2 or more different functional group, the highest priority group, the priority order is selected as a characteristic group for the principal functional groups or main functional groups, while all the remaining groups are called as a secondary functional groups, is treated as a substituents. So this is the order of the priority of selecting the principal functional group is as follows. So SO3H, COOH or CO2O, or first SO3H, then COOH, and then COO or CO2O or COO or C double bond OX, the halogen C double bond O amido, and then nitro, and then C double bond O and C double bond O OH NH2. So this is the order of the priority. So it may be noted that while writing the name of the polyfunctional compounds, a principal functional group is indicated by adding the secondary suffix after the primary suffix, while the secondary functional groups are indicated by adding suitable prefixes before the word root. The secondary suffixes of some of the principal functional groups along with their corresponding prefixes when they are treated as the secondary functional groups is listed below. So it may be noted that while writing the names of the polyfunctional compounds, compounds, the principal functional group is indicated by adding the secondary suffix after the primary suffix, while the secondary functional group are indicated by adding the suitable prefixes before the word root. So it may be noted that while writing the names of the polyfunctional compounds, the principal functional group is indicated by adding secondary suffix after the primary suffix, while the secondary functional group is indicated by adding suitable prefixes before the word root. The secondary suffixes of some of the principal functional groups along with their corresponding prefixes when they are treated as a secondary functional group is listed below. So you have to read this characteristic group, a prefix as well as a suffix. So prefix means carboxy, suffix means carboxylic acid. So carb alkoxy or alkoxy carbonyl, alkyl carboxylate. Alkyl O8. So ester. So then halocarbonyl or carbonyl halide, halocarbonyl or carbonyl halide, and then oil halide, and then carbomyl carboxamide. Here amide, and then formyl or aldo carbaldehyde. Here cyano or carbonitrile. Here nitrile alone, and then oxo or keto. One hydroxy O hydroxy OL, suffixes of alcohol, so OL, prefixes hydroxy. So NH2 amino amine, O means oxa alkoxy, NOH means hydroxy imino oxime. So NH2 means hydrazone, yeah, hydrazone, and then hydrazine zone. So this is the characteristic group as well as a prefix as well as suffix we have to read. So note the chain terminating functional group with their carbon atoms are shown in the brackets given in the above table. They are part of the respective acyclic principal chain where the carbon atoms of these groups are shown without the brackets. So these are not part of the principal chain. While selecting the principal chain, while selecting the principal chain present in the polyfunctional compound, care should be taken must contain the principal functional group and the maximum number of the secondary functional group and the multiple bonds, if any. So selection of the principal chain is nothing but while selecting the principal chain present in the polyfunctional compound, care should be taken that the principal functional group and the maximum number of the secondary functional groups and multiple bonds, if any. Numbering of the principal chain, the principal chain can present in the polyfunctional compound has to be numbered in such a way that the principal group gets the lowest possible number, followed by the double and triple bond and their substituents. So the principal chain present in the polyfunctional compounds, it must be numbered in such a way that the principal group gets the lowest possible number, followed by the double as well as a triple bond and the substituents. So the principal chain present in the polyfunctional compound, it must be numbered in such a way that the principal group gets the lowest possible number, followed by the double bond as well as a triple bond and their substituents. So the principal chain present in the polyfunctional compound, it should be numbered in such a way that the principal group gets the lowest possible number, followed by the double bond and their substituents. Alphabetical order, the prefixes of the secondary functional groups and then other substituents should be written in alphabetical order, and the word root is explained earlier. So the rest of the rules for the numerical prefixes and the same explained, the prefixes for the secondary functional group and the other substituent should be written in an alphabetical order below the word root as explained earlier. The result of the rules for the numerical prefixes are same explained. 2-methyl-3-oxobutanoic acid. So this is the example. So these are all the chain terminating functional functional group with their carbon atom shows the brackets given in the above table or the part of the respective acyclic principal chains, while the carbon atoms of these groups which are shown without the brackets are not the part of their principal chains. Selecting the principal chain, while selecting the principal chain is present in the polyfunctional compounds, the care should be taken that it must contain the principal functional group and the maximum number of secondary functional group and the multiple bonds if any. Numbering the principal chain, and the principal chain present in the polyfunctional compounds, it must be numbered in such a way that the principal group gets the lowest possible number followed by the double bond as well as a triple bond and their substituents. So the chain terminating functional group with their carbon atoms shown in the brackets or given in the above table, these are all the part of their respective acyclic principal chains, while the carbon atoms of these groups which are shown without the brackets, these are all the part of their principal chains. Selecting the principal chain, while selecting the principal chain present in the polyfunctional compound, care should be taken that it must contain the principal functional group and the maximum number of secondary functional group and the multiple bonds. This is the example 2-methyl-3-oxo butanoic acid, ethyl 2-methyl-3-oxo-butanate. So these are all the two examples of how they were numbered 1, 2, 3, 4. So this is the carboxylic acid for butanoic acid. Third question oxo. So third 3-oxo. Second question methyl. Here 1, 2, 3, 4. Second question methyl 3-oxo ethyl butanate with butanate. Okay. So here we are getting some example, that is 1, 2, 3, 4. So second position ethyl, so 2 ethyl, and then 2 ethyl, 2 methyl, yes, and then 3 oxo butanoate. So here 3 carboxamido pent 3 enoic acid. So 1, 2, 3, 4, 5. Okay. Primary, that is carboxamido 1, 2, 3 carboxamido pent 5 carbon atom CNE. So here carboxylic acid, enoic acid. So here we are going to write 5, 4, 3, 2, 1. And then second position chloro 2, 2 chloromethyl 3 oxo pent 4 enamide. Yes, amide group is a functional group. Here 1, 2, 3, 4. So 4 enoic acid but 3 carbox ethyloxy but 2 enoic acid. So 4 1, 2, 3, 4. So first position ethyloxy but 2 enoic acid. Ethyl 4 cyano 3 methoxy butanoate. So this is the example 1, 2, 3, 4. While numbering 4 cyano, fourth position cyano, and then ethyl, this is the first position, and then 3 methoxy, 4 carbon atoms butanoate. If C2H5 is there, O8, it should be ended with O8. Then carboxylic acid, oic acid, it should be ended with oic acid. Amide group is enamide, it should be ended with amide. So oxime. The prefix hydroxy immuno is attached to the name of the parent hydrate when it is present at the secondary functional group, and the prefix hydroxy immuno is attached to the name of the parent hydrate when it is present as the secondary functional group. For example, so hydroxy group is attached to the nitrogen atom, means it is said to be hydroxy immuno. The hydroxy immuno is attached to the name of the parent hydrate when it is present as the secondary functional group. For example, OHN double bond COOH, that is cyclohexane. First position carboxylic acid. So 1 carboxylic acid, cyclohexane is there. Then fourth position hydroxy immuno. So 4 hydroxy immuno, cyclohexane, 1 carboxylic acid. When oxime is the principal functional group, the name oxime is placed as a separate word for the name of the aldehyde as well as a ketone. For example, so nitrogen is attached with the hydroxy group. Hydroxy group is attached to the nitrogen, means it is said to be the hydroxy immuno, and the nitrogen is attached to the hydroxy group, it is said to be the oxime. 1, 2, 3, 4, 5. So here pent 5 carbon atoms. So 1, 2, 3, 4, 5. Yes, 5 carbon atoms spent. Third position, 1 oxime. Third position, 1 oxime. So once again, I will repeat the oxime. So the prefix hydroxyimmuno is attached to the name of the parent hydrate when it is present as the secondary functional group. For example, hydroxy, that is hydroxy group is attached to the nitrogen, is hydroxyimmuno. Nitrogen is attached to the hydroxy group, means it is said to be the oxime. So in this example is given with the cyclohexane. In first position, carboxylic acid is there, and then in fourth position, hydroxyimmuno is there. So it is a cyclohexane. It is attached to the cyclohexane. Is the main compound. So 4-hydroxyimmunocyclohexane, 1 carboxylic acid. So when oxime is the principal functional group, the name oxime is placed as the separate word after the name of the aldehyde or ketone. For example, pentane 3,1 oxime. That's what I said. Nitrogen is attached to the hydroxy group, means it is said to be the oxime. It is considered as the principal functional group. Next is the hydrozones. The prefix hydrozono is attached to the name of the parent hydrate when it is present as the secondary functional group. The prefix hydrozono is attached to the name of the parent hydrate when it is present as the secondary functional group. The prefix hydrozono means it is a hydrozono. It is attached in the fourth position, and first position carboxylic acid is there, and then again the principal chain is the cyclohexane. So hydrozono cyclohexane, 1 carboxylic acid. The prefix hydrozono is attached to the name of the parent hydrate when it is present as the secondary functional group. So hydrogen, that is amido group is attached to the nitrogen, means 4 hydrozono cyclohexane, 1 carboxylic acid. So in cyclohexane, carboxylic acid is attached to the first position, and then 4 hydrozono. We have to mention at that 4 hydrozono. When it is present as the principal functional group, it is named by placing the name hydrazone as a separate word after the name of the corresponding aldehyde as well as the ketones. So propanol hydrazone. So N after amido group is coming. Hydrazone means amine group is coming before the nitrogen atoms, and hydrazone means N after amino group is coming. So when it is present as the principal functional group, it is named by placing the name hydrazone as a separate word after the name of the corresponding aldehyde or ketones. After the corresponding aldehyde or ketones. For example, diazine, the compound is named as the derivative of the diazine. For example, 4-chlorophenyl, 3-chlorophenyl diazine. This is an example for the diazine. That is, diazonium compound is nothing but N double bond N is said to be the diazonium compound. It is attached to the chloro. That is, fourth position chlorine is there, and phenyl, diphenyl is there. Diphenyl compound is there. So in third position chloro is there. So 3-chlorophenyl diazine. 4-chlorophenyl. It is coming as a secondary prefix and ending is a diazine. For some additional rules for solving the compounds, select the chain as the principal chain which contains the maximum number of the radicals as a secondary suffix. CH3, CH, CH, alcohol is attached, and CH, CH2, CH2, OH. So 1, 2, 3, 4 is the numbering, and 1, 2, 3, 4, 5, 6 is here. That is hexane is there. 1, 4, 5 triol. 3, 4 chlorobutyl hexane. 1, 4, 5 triol. Same in different chains, selected as the longest possible chain. Hydroxy CH2, that is hydroxy group is there. That is 1, 2, 3, 4, 5, 1, 2, 3. That is double bond will should be always given at the lowest number. That is a functional group followed by the double bond, followed by the triple bond, followed by the substituents. So 5,3-hydroxy, 1 propanol, non 3,6 diene, 1,9 diol. So all the things being equal, the principal chain must contain the maximum number of the double bonds. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So here 1, 2, 3, 4, 5, 4 hydroxy YNY non 2,6 diene 1,9 diol. So same in a different chain. That is, all the things being equal, principal chain must contain a maximum number of the double bonds. So 5, 4, 4 hydroxy Y and Y, non 2, 6 diene 1, 9 diol. So alcohol is there means OL. It should end with the OL. Dienes means one principal chain should contain 2 double bonds, and di YNE means one principal chain should contain 3 triple bond. That is two triple bond, and then here 4 in bracket 4 hydroxy Y and Y, non 2, 6 diene 1, 9 diol. So we are going to see some same, that is hydrozono. From hydrozones I'll explain. The prefix hydrozono is attached to the name of the parent hydrate when it is present as a secondary functional group. For example, H2N double bond, that is N before H2N. Amino group is coming means it is said to be the hydrozono. N after the amino group is coming, it's said to be the hydrazone. So CH3, CH2, CH double bond, so N bond NH2. So propanol, that is 3 carbon atoms. So propanol hydrazone. Diazine, the compound is named as the derivative of diazine. For example, 4 chlorophenyl, 3 chlorophenyl diazine. Some additional rules for solving the complex compounds. Select the chain as the principal chain which contains maximum number of the radicals of the secondary suffix. So this is the example: 3, 4, chlorobutyl hexane, 1, 4, 5 triol.